So here's what you're going to start with today. You're going to write some solutions to this inequality. You're going to just put it on the number line and say, these are some of them that work. Not even all of them, just some of them. Then you're going to write a solution that works for this inequality. So looking at this first one, who's got something for me that is less than or equal to 9.2? Micah?
-5.
-5. I'm just going to mark it on here. Okay, that's true. Yeah, still.
9.2.
9.2, so like right there. That does work. Yeah.
9.19.
Okay, try to put that one right there, 9.19. What else works? Let's get one more. Tess, you got one for me? What's something that's less than or equal to 9.2? 9, okay. So, a dot on 9.2 and everything left forever would work. Now, looking at this one, who's got something for x that works? And how do you know? Nancy?
14 if x is 1.
Okay, so you're saying if x is 1. That would mean 14 is greater than 14, though.
No, x is 0.
Oh, so if x is 0, it works? X could equal 0, okay. What are some other things for x, Ash?
-2.
-2 would work because that'd be 3 plus 5. Okay. Bob? -1 million would work. Yep. Still?
-5.
-5 would work. Yeah, Will Baker?
I think that was it.
Okay. So pretty much, here's what I want you to get from this. Do you guys see that if it is 1, it is equal? Are you guys seeing that?
Yeah.
So anything less than 1 works. Cool.
Couldn't you just simplify it?
Well, Micah, what you're saying is, could you just solve it? This is what Micah's saying to do. Yeah, we could have done that, Micah.
Or if you wanted to make it easy, you could just divide both sides by 7.
Okay, it's orchard time, baby. I'm sure some of us have already been to an orchard this year. I've been to one. I go to that Ed Dunbeck and Daughters one. That's our gym. So there's 2 orchards, and you're going for a class field trip. You're going on a class field trip. Orchard A is $9 per person, but requires 3 chaperones. Orchard B, $10 per person, but you only need 1 chaperone. Same price for kids and adults. There's no like kid price, adult price. So we want to know what is cheaper if there's 8 students, 12 students, or 30 students. What's the best deal out there at the orchard? So as I'm looking at these orchards, all right, this one is $9 per person. So if we have 8 and 3 chaperones, right? So I'd like to think of like $9 per the number of students plus 3 chaperones. I kind of like to think of that. And then B is like $10 per person, number of students, and 1 chaperone. That's right where my head went with the expressions. So for 8 students, Orchard B is cheaper. Because if I throw 8 up in here, it's 90 for B, and it is 99 for A. Okay. 12 students, guess what? Still B. 12 students, 15 times 9 is 90 plus 45, 135. If we go with the other, it's 130. What do you notice about for B? Is it getting closer or further? Getting closer. So 30 students, which one's cheaper? A. Because 9 times 33 is 270 plus 27, 297. And B? 310. So here's what the teacher wrote down to look at the different prices depending on students next. This inequality right here. So it's your job. What does n mean? What would this equation mean? And what does the solution to this tell us? Then I want you to graph it. Let's go. So what does n mean? Who can tell me what n is in our context? Yeah, Emmett?
Students, like number of students.
Number of students. I agree. Okay, and then what does the equation mean? B. What does that mean? Finn?
Oh, that that Orchard A and Orchard B are the same price.
Yeah, so when A and B are the same price. Okay, and when are they the same price? How many kids?
17.
It's 17 kids, right? And you can get that by solving for n. All right, next up. What does C mean? What does the solution to that mean? Yeah. Yeah, or I would say like when A is less than B, but also that would tell you when B is more than A, right? So graphing it, we know 17 kids. Let's say that's right here. Does 17 work to be less than?
No.
So it's going to be open. And here's what gets a little tricky. Is A a better deal when we have more people or less people? More people. So it looks like a less than symbol. But actually the solution is things that are more. We know it from our context. And here, there is a reason for that, Evan. The reason is this. If we were to solve it, we would distribute. Okay. We'd solve for n. Look where the variable ends up being. It ends up being on the other side. So n, like if we don't flip it, it says 17 is less than n. That means n has to be more than that for A to be the better price. No, 17 is less than. And n, the number of students, when it's more than 17, A is the better deal. So you can kind of see it when we solve it, flips which side the variable kind of is on there.
Wait, if you flipped it back, would it be n?
Well, I would,
greater than 17?
yeah, I would always write it like this, but these are the same.
Yeah.
Yeah, but I would always write it like this myself.
Yeah. Okay.
Cool. Next, you go to solve this equation and then try to transfer that same knowledge like we just did by testing out some points to get a solution to the inequality. So start with the equation and then move toward the inequality. You'll notice the equation and inequality have the same expressions on each side. I'm going to maybe solve it different than I see anywhere else, which is cool. What I did was, to solve the equation, I multiplied both sides by 5 first. And that gave me negative 4x plus 3 equals 20x minus 60.
How would it be negative 4x?
Because this negative. Okay, and then I'm going to get x on the same side. Add 60. Oh, I did something
Wait, no,
different.
negative 4x is 12. 12 times 4.
I did something here.
It's supposed to be negative 4x.
Oh, 12 right here. Yeah. I forgot to distribute. There we go. Let me do that again. I think I did something wrong. I'm going to back up, guys. Sometimes that happens. I think I skipped a step. Here we go. I'm going to multiply both sides by 5. And that gives me. I'm going to not do my distribution yet. 20x minus 60. All right. Next, I'm going to distribute my negative 4. The back of the room chatter I should not be hearing right now, y'all. There it is. There it is. Okay, now I'm going to get x on the same side by adding 4x. So negative 12 equals 24x plus 60. I'm going to subtract 60. Negative 2 equals 24x.
No, you messed it up again.
What did I do this time?
You were supposed to, so it was minus 60, it wasn't plus 60, so you gotta add 60.
Oh, geez, I changed my symbol. Good, now it's working out how I wanted to. There it is. X is 2. I was writing in a cramped space, couldn't see my symbol. So we have x equals 2. Well, this is an inequality, right? So 2 is my reference spot. Notice this is or equal to. So at 2, should I have a solid or open dot? Solid, because 2 works. And then we got to figure out, are things less than 2 go to work or things bigger than 2 go to work? There's a very nice number to test. Guess which number? 0. Okay, so I'm going to put 0 in for x on both sides. On this side, I get negative 12. That's kind of done. On this side, I get negative 12 fifths. So looking at the inequality, is that true? Is negative 12 fifths less than negative 12? No, it's more than. So 0 didn't work. Which way must my graph go? It's like DJ Khaled. Nothing can stop it. Yeah, you know what I'm talking about. It's all the way up. Forever. So what I'm going to look at with you is the 2 ways to solve number 3. I just want to get you started because I think it could be pretty tough. So this is over 4 plus 5 is greater than or equal to 7x plus 5 over 3. The most common way I would see students try to solve this is by getting everything to be a fraction first. So I'll do that on the right side. They would do something like negative 5 halves plus 1/4 x plus 5 is greater than or equal to 7/3 x plus 5/3. So wherever they just do the division, that's like the number 1 way I would see students do this. Okay. 10/4 is 5 halves. Okay. Let me show you what I would do. I would make all these into fractions with a common denominator. So what I would do different, and I think is easier, is I would make these all have a common denominator of 12. Okay? So I would take each chunk and make it an equivalent equation with a denominator of 12. So instead of 4 to 12, that'd be negative 30 plus 3x over 12. These are the same fraction, right? To make an equivalent of fraction, for example, 1/2, if I multiply both by 5, I get 5/10. Those are equivalent, right? Multiply both top and bottom by the same thing, we get equivalent fractions. So for 5 to have a denominator of 12, it has to be 60 twelfths. And then for the last one to have a denominator of 12, it has to be 28x plus 20 twelfths. And you might be thinking, Mr. Mack, why am I doing all this? Well, the reason is, once I have everything with a like denominator, I can multiply both sides by 12. And it leaves me with negative 30 plus 3x plus 60 is greater than or equal to 28x plus 20. Now there's no fractions anywhere once I've gotten a like denominator and multiplied both sides by 12. I multiplied by 12. They're all
if you do on the same on both sides.
Yeah, same on both sides. I've had an issue with negatives this hour. Thanks for pointing that out. This was a negative 5, which means that this one right here would be a negative 20. I had an issue with symbols today.
It happens to the best of us.
It happens, yeah. So this one should be negative 20 as well. Okay, we fixed it. Thanks for saying something, Ed. Did I forget it up here too? I did forget it. Well, it's because my original. That should be a negative 5/3. If you're gonna go after fractions, that's fine. These fractions will work out just as well. If you don't want to do the fractions, you can get them to have a like denominator and then eliminate your denominator. Okay? So you'd have to pick which one's best for you. All right, homework to the bell, friends.